this thing to make it work. So this thing operates at 6 milliliters per minute of flow. Okay, so again, very little flow, and because of that, we use, again, very little power, or relatively little power to pump through it. We actually, we haven't optimized the pump yet. We essentially just use some of the shelf fans put together to provide the required flow. Okay, but again, this whole device is very small. It's about the size of a memory stick. Here are some of the results that we did when we exposed this device to particulate matter. In this case, we exposed it to tobacco smoke. Actually, here at LBNL, this was done in Building 63 in the smoking chamber there. Huh? So the way we would do this is, first of all, we would use a dust track, which is an optical instrument, essentially to measure particulate matter. We calibrated the dust track with gravimetrically, right? So we know what the tooling factor for that was, and then we would essentially use that to track the concentration in the chamber. We would lit a cigarette, so you can actually see the cigarette would be lit here. The concentration, which corresponds to this axis here, would rise very quickly. The cigarette goes out, and we see a decay in the concentration as the smoke settles, right? Then we would use a HEPA filter to actually drop the concentration down. As opposed to just wait for this thing to decay exponentially, we would just speed things up a little bit to see what the sensitivity was at the different levels for our device. Okay, so this is these abrupt changes. Now, again, the device works by essentially adding mass to that resonator, right? So as the resonator becomes heavier, the frequency should go down. Okay, so then what we would track is the rate of the frequency change of the resonator, right? Because for a given concentration,